Hello and welcome to this midterm review video, which is going to be proof-based. So I'm going to take you through a series of 11 proofs that should be a decent review of different skills that we've learned throughout the first half of the school year. So here we are looking at number 1, where I'm giving you triangles ABC and EDC, where C is the midpoint of BD and AE. I want to prove that two lines are parallel, AB and DE. So I'm just going to highlight those so that they stand out. All right, so I'm looking to make these two lines parallel. The way to make lines parallel or prove lines are parallel is by showing angles are congruent. So that could be alternate interiors, corresponding angles, alternate exteriors, things like that. Now, if I have these two triangles, and I know C is the midpoint of both BD and AE, that means that a midpoint divides a segment into two congruent segments. So I can mark a couple pairs of congruent segments in this image. Additionally, if I call these angles 1 and 2, I'm seeing vertical angles congruent. So now that I've marked up my picture with everything that's true based on my givens and anything I can just draw from the diagram, which would be the vertical angles, I'm noticing ABC is congruent to DCE by side, angle, side. Okay, now think about this. If our triangles are congruent, wouldn't it make sense that their corresponding angles are congruent? If those angles, B and D, are congruent, those look like alternate interior angles because they form that Z shape. So if alternate interior angles are congruent, then lines are parallel. All right, and that's what we're going to write up. First things first, we always write down our given. So I'm going to say C is the midpoint of BD and AE. All right, now let's talk about that midpoint first. So I knew that as a result of that, AC is congruent to CE, and BC is congruent to CD. All right, and my justification is a midpoint divides a segment into two congruent segments. Okay, step 3, let's talk about those vertical angles. All right, now I'm looking to get my triangles congruent. Did I talk about everything I wanted to talk about? Meaning, did I talk about side angle side to be able to draw the triangles congruent by side angle side? Well, here's a pair of sides, here's a pair of sides, and there's the angle. All right, so I did a nice little fact check because sometimes it's easy to forget to talk about stuff when doing these proofs. So I talked about everything I need to talk about, so therefore I now can get to the triangles being congruent. Now make sure you say it in the correct corresponding order, meaning side AC corresponds to EC and CB corresponds to CD. So I'll say triangle ACB is congruent to triangle, now again following that correspondence would be ECD. And that's by side angle side. Now the whole point of getting these triangles congruent is that I can say angle B and angle D are congruent. Because those are corresponding parts of congruent triangles, which then are alternate interior angles, which helps me get my lines parallel. So since we're proving lines parallel, we're not saying if two parallel lines, we're saying if the angles. So if alternate interior angles are congruent, lines are parallel. And this makes sense because who are the alternate interior angles? They were angles B and D that I previously proved. Then it must be true that lines are parallel. Oh, hey, there they are. AB is parallel to DE. All right, moving on to proof number 2. I'm giving you that DAV, triangle DAV, is congruent to triangle EVA, and DE is parallel to AV. I want to prove that DAVE is an isosceles trapezoid. Now, anytime you're proving an isosceles trapezoid, you need to make sure you do trapezoid first. Now, here's the good news. Just solely based on the givens, I know that this is a trapezoid because it has at least one pair of opposite sides parallel. So this right here is going to help me that. Now, in order to prove it's an isosceles trapezoid, you should think about 3 things. Can you get legs congruent? Can you get base angles congruent? Can you get diagonals congruent? Any one of those would be sufficient. Now, with this given, I'm going to do some highlighting. You have DAV congruent to EVA. So you actually could do a lot with this. You could talk about the legs, because those are corresponding sides of those congruent triangles. You technically could also talk about this angle DAV being congruent to DVA, and those would be base angles. And if you want to get real fancy, you even could talk about DV being congruent to AE, and those would be diagonals congruent. So you really have a lot of options. I'm personally going to go for legs because that's just the first thing that I saw. All right, so again, we write our givens. All right, quickly inserted those for me. Now let's talk about it being a trapezoid at step 2. I love that this is called Dave. Is a trapezoid. All right. So if at least one pair of opposite sides is parallel, the quad is a trapezoid. Awesome. Now I got to take care of getting it to be isosceles. So let's talk about our legs being congruent. But remember, those were corresponding sides of our congruent triangles. All right, now that I've talked about everything I need to talk about as far as getting the legs and it's a trapezoid, I can conclude it's an isosceles trapezoid. Oops, I wrote that just like a regular name. D-A-V-E, Dave, is an isosceles trapezoid if legs are congruent. The trapezoid is an isosceles trapezoid. All right, and that's that one. All right, moving on to proof number 3. So I'm giving you that angle 1 is congruent to angle 4, and angle 2 is congruent to angle 3. Also telling you AC is congruent to BD. And I want to prove that ABD, so that's this triangle right here, is congruent to BAC, which is this triangle right here. Okay, so first thing I'm noticing is that these are overlapping, so I'm going to take a moment to pull these figures apart. So that means I'll have this be ACB. That's the one I just went over in this blue color. And then this will be my other one in yellow. Okay, always pull apart overlapping triangles because it helps you see things better. Maybe I insert some numbers in here too that were helpful. So like in my blue triangle, here's 3. And that's actually 1 and 2 together. That might be helpful, so we'll keep that in mind. And then my yellow triangle, here's angle 2. And that's where I put my double arcs. Okay, so my thought process here, just looking at my pictures that I pulled apart, is that these two triangles are overlapping at a shared side right here at AB. So let's mark that with an X, and that's our reflexive property. So as far as getting these triangles congruent goes, I see angle, side. Now, remember what I said about this over here. We haven't really talked about angles 1 and 4, yet they gave them to me to be congruent. Well, if 1 and 4 are congruent and 2 and 3 are congruent, I can add these together, and then those would be congruent. So as a result, this whole angle A would be congruent to this whole angle B. And now that I have that in my picture that I pulled my figures apart, I can see that these triangles would be congruent by angle, side, angle. So I'm going to have to go through a little bit of addition of angles to do this, no big deal, but then that should get our triangles congruent. All right, first things first, let's insert our givens. Boom. And then step 2, let's knock out that reflexive property because that's really easy. All right, so let's now start the process of addition. So the things I'm going to be adding that I already know are equal are 1 and 4 being added to 2 and 3. So let's write angle 1 plus angle 2 equals angle 3 plus angle 4. Now, what's another name for 1 and 2? Well, 1 plus 2 is the same thing as CAB. So I'll write that right below it. What's another name for 3 plus 4? DBA. And notice how I'm using those 3 letters because in the diagram, if I just say angle A, it's kind of confusing because there's actually 3 angle A's. So use 3 letters to really denote this whole angle. Okay, so 1 plus 2 is the same thing as CAB. 3 plus 4 is the same thing as DBA. And that's just our addition. Okay, so again, we're trying to prove our triangle's congruent. So let's see, what have we talked about that's helpful? Remember we said angle, side, angle. So this was our side. These were the angles. So I need another angle. Now they gave me 2 and 3 being congruent. So that is my third piece of information. So I've talked about everything I need to talk about. So now at step 4, I can say triangle ABD is congruent to triangle BAC by angle, side, angle. And then we're done. Now, what's funny about this proof though is I actually could have done it another way, which upon looking at this again, I actually could have done this by side, angle, side as well, or angle, angle, side, I believe. So something that I actually marked in my original picture, and then I forgot to mark it at this next part. Remember how I said that these were congruent? So if I re-put that back in, there's AC, here's DB. Still using addition, I really could have done side, angle, side. So really all that would change is, well, I guess really nothing, like if you think about it, because here was the other side. I talked about the angles to add and I did the reflexive property, so I really could have done side angle side. Additionally, if I didn't see this reflexive property, I really could have done angle side. So there really were 3 different ways to do this problem based on the given. So I'll just add this here again, angle side, if you really wanted to. But funny enough for me, when I pulled the triangles apart, I just realized I actually didn't even need these sides in order to get these congruent, as long as I did my angle addition in order to do the angle side angle. So something just interesting to think about. So there are a few ways to do this, but this was a great way for us to even talk about the addition of our angles while pulling the figures apart and maybe seeing something a little bit of a different way. All right, moving on to proof number 4. I'm giving you that CAB, which is this whole angle, is congruent to DBA, which is that whole angle. And I'm also giving you angle 1 congruent to angle 4. Okay, I want to show that AXB, which is this figure right here, is isosceles. Okay, so let's think about this backwards. If I want to prove that a triangle is isosceles, that means I need to prove 2 sides congruent. So my goal is probably to try to get this side right here congruent to this side. So that's AX and XB. Now, if those sides are congruent, that means the opposite angles should also be congruent. So that would be 2 and 3. So can I prove that angles 2 and 3 are congruent based on my givens, which would then lead me to my opposite sides being congruent, which would then lead me to the triangle being isosceles. Now, based on the givens, they're giving me a whole angle and parts of those whole angles. So if I do whole minus part, that will leave me with the other part. So I'm thinking subtraction of angles will be our way to accomplish this. All right, so let's put our givens in there. And done. So I'm going to take my whole angle, which was angle CAB, which is this angle over here, and we're going to subtract away angle 1. Now that's going to be the same as this whole angle, which is DBA. Take away this part of the angle, which was angle 4. Okay, now what's another name for CAB minus angle 1? Well, that's going to leave me with angle 2. And what's another name for DBA minus angle 4? That's going to be angle 3. And that's my subtraction. Okay, so now that I know that 2 is congruent to 3, if 2 angles of a triangle are congruent, the sides opposite will be congruent. So at step 3, I can say AX is congruent to BX because if 2 angles of a triangle are congruent, the sides opposite them are congruent. All right, awesome. So now that I have 2 sides congruent, that means by definition, this must be an isosceles triangle. So at step 4, we'll say triangle AXB is isosceles if 2 sides of a triangle are congruent. It is isosceles. All right, done with that one. All right, moving on to proof number 5. I have YX, which is right here, congruent to WX. And ZX, which is right here, bisects angle YXW. So automatically I'm thinking that these 2 angles right up here are congruent. Okay, I want to prove that YZ, which is right here, is congruent to WZ. Okay, so my first thought here is that I want to try to get triangles congruent that contain those sides, because then the corresponding sides would be congruent. So can I get this whole triangle congruent to this whole triangle based on the givens? Now they gave me a side or a pair of sides, and they basically gave me those angles. I'm going to have to do a little work to get there, but not much. But I'm noticing they have a shared side right here at XOZ, and that's just my reflexive property. So by side, angle, side, these triangles would be congruent. All right, so let's put our givens in there. Okay, done. Let's talk about the angle bisector. So I'm going to say angle YXO is congruent to WXO, because an angle bisector divides an angle into two congruent angles. Okay. Now what we can do is talk about that reflexive property at XZ. All right, now did I talk about everything I need to talk about? Remember we said this was going to be a side angle side proof. They gave me a set of sides. I got my angles congruent, and I got my third piece of info with the other side. So yes, I talked about everything I needed to talk about to get the triangles congruent. Now in the corresponding order, we're going to say YXZ is congruent to triangle WXZ. And that's side angle side. Now again, once I have these triangles congruent, that means their corresponding sides are congruent. So at step 5, I can say YZ is congruent to, WZ. Technically wouldn't have mattered if I flipped it. And that is because corresponding parts of congruent triangles are congruent. And a good way to even double check your correspondence is just looking at the triangles you listed up above. YZ is the first and third slot, as is WZ. So this confirms that I wrote my triangles correctly, because now these would be corresponding sides with that correct lettering.
All right, we are picking up now with proof number 6, where they're telling me that YX is congruent to WX, and YW, which is this segment right here, is perpendicular to XZ. So I'm just going to put a couple right angles in there. I want to prove that XYO, which is right in here, XYO, that's that little angle, is congruent to XWO. Okay, so right where I put the little green markers, that's where I'm trying to get them congruent. Truthfully, a really quick way to do this is, if this is a triangle, if two sides of a triangle are congruent, the angles opposite are congruent, and this would be a very short proof. However, I'm going to want to take us a certain other route to practice something, and I'm going to use these right angles to do it. Now, my thought process is, can I get these two triangles congruent? Because then if I can get the triangles congruent, then the corresponding angles must be congruent. Now, if you don't think of the first thing that I said and you take this route that I'm about to take us on, this journey, you're going to notice that XO is congruent to itself by the reflexive property. So as a result, when you guys look at my markings, it looks like side-side angle, which we know is not a thing. So instead, because these are right triangles, I'm going to use hypotenuse leg, where the hypotenuse is the side opposite the right angle. Now, just like side angle side, side angle side, where you're looking to prove 3 pieces of information in order to get the triangles congruent, it's the same thing with HL. It's just that your 3rd piece of information is proving that you have a right triangle, which is why we gave you the perpendiculars. Okay? All right, so now that we have our game plan, get the triangles congruent, then their corresponding angles, let's write up our proof. So first thing first is our givens. Done. Okay, so now let's talk about these perpendiculars. The whole point of the perpendiculars is to get right angles, which helps me get right triangles. So at step 2, I'm going to say angle XOY and angle XOW are right triangles. And that's because oh shoot, no, I messed up. Let me back it up a minute. I got ahead of myself. They are right angles. I'll get to right triangles in a second. Okay, so XOW and XOY are right angles because perpendicular lines form right angles. Then we can say we have right triangles. So I'll say triangle XOW and triangle XOY. Are right triangles. If a triangle has a right angle, it's a right triangle. Okay, good. So now I've gotten that piece of information taken care of. The hypotenuses were actually given to me, so that is also fine. Now the leg is going to be this XO. All right, so now that I have the hypotenuse, the leg, and the right triangle in my proof, I can say my triangles are congruent. And that's by HL. Okay, now at step 6, I can say my angles are congruent. Because corresponding parts of congruent triangles are congruent. Okay, great. So again, I kind of took you guys on this longer journey in order to get us to review HL, but there really was a shorter way if I wanted to use the fact that this whole shape was a triangle, and if 2 sides of a triangle are congruent, the angles opposite are congruent. So that would be the faster way, but this is also another totally valid way, which helps us review some HL. All right, moving on to proof 7. So I already put my givens in my proof. Let me mark up my picture. I'm giving you PS, that whole segment congruent to RS, angle 1 congruent to angle 2, and Q is the midpoint of PR. So I'm already thinking, all right, so these 2 segments will be congruent, so make sure I talk about that. I am looking to prove that angle 3 and angle 4 are congruent. Okay, so right off the bat, looking at this picture, my thought process is probably about getting triangles congruent. If I can get some triangles congruent, that would give me some more information about who else is congruent, meaning corresponding sides and angles, and how that could help me. So kind of looking at my picture, I'm thinking to myself, can I get this triangle congruent to this triangle? Now, how would that help me? Well, if I know those 2 triangles are congruent, then the corresponding angles would be congruent. So that would be these guys right up here. And the reason I chose those is because if I can get that these 2 angles are congruent, then that means their supplements due to linear pairs would have to also be congruent, and then that would be the proof. Now, right now, based on what they gave me, I'm seeing an angle and a side. Now, that's just based on these two givens. There has to be a reason they gave me this. This PS is congruent to RS. Now, this is a very popular thing that students overlook. This is just one giant triangle. And if this is one giant triangle and two sides of them are congruent, that means the opposite angles would be congruent. So that means angle P must be congruent to angle R. And now it's an angle side angle proof. So again, my thought process is if I can get those two triangles, the blue and the pink one, congruent by angle side angle, then I would know by corresponding parts that 5 and 6 are congruent, and then supplements of congruent angles are congruent, and then my proof is done. All right, so this is a little bit more of a lengthy one to go through with you guys, but it reviews a lot of really good skills for us. All right, so first thing I'm going to talk about is, actually, let's do that midpoint, because I took care of that in my diagram like right away. Let's talk about PQ and QR. All right, that helps me get a side in my proof. Remember, we want angle side angle. They gave me angle 1 and 2, so that helps me. All right, so now I have to talk about the other angle. So that would be P and R. All right, awesome. Okay, so now I have angle side angle in my proof. I've talked about everything I need to talk about. So now at step 4, I can say my triangles are congruent. So make sure you're saying it in the corresponding order. I'll say TQP and VQR. Okay, awesome. Now, remember what we were trying to do with this. Now that I know that those are congruent, at step 5, I can say angle 5 is congruent to angle 6 because corresponding parts of congruent triangles are congruent. All right, almost there. It's going to take just 2 more steps. Now I have to use the fact that these are supplementary and these are supplementary to get to 3 and 4, because that's my end goal here. So I'm going to say angle 5 is supplementary to angle 3, and angle 6 is supplementary to angle 4, because linear pairs are supplementary. Okay, now our last step is that 3 is congruent to 4, and the most popular misconception is by substitution, but substitution is when you have equals plugged in for equals, and that's not what's happening here. I'm not saying 5 is congruent to 3, I'm saying they're supplementary. So my justification is supplements of congruent angles are congruent. And here's why that statement even makes sense. When I say supplements of congruent angles, who are the congruent angles I'm talking about? That was 5 and 6. 3 is supplementary to 5. 4 is supplementary to 6. Because they are supplements of angles that I've already stated are congruent, then it must be true that 3 is congruent to 4. And that's why that statement makes sense. So again, a very popular misconception when dealing with supplements is students want to say substitution, but that's not what's happening here. So I'll put a little note. All right, moving on to our next proof, proof 8. I'm giving you some perpendiculars, and perpendicular lines form right angles. I have PQ, which is where? Oh, here. PQ is congruent to ST, So that's this whole segment congruent to this whole segment. And PS congruent to RU. All right, and I want to prove that angle 1 is congruent to angle 3. Okay, so similar to the last proof I just did, I'm now thinking, can I get angle 2 congruent to angle 4? Because then if I can get those congruent, then I can do supplements to work towards angles 1 and 3. 2 and 4 are very clearly a part of overlapping triangles, so let's see what happens if I pull them apart. So I'm going to use green to pull apart this triangle. And I'll use blue to pull apart this one. All right, and then do some more labeling. These are supposed to be right angles, but it is what it is. So P, R, Q, S, U, T, Q, P, and T, S. Okay, now with that overlapping triangle situation, I'm noticing that PS is congruent to RU, but they're overlapping here at SR, which means if I can add these segments together, that gives me a whole other side, which would give me PR congruent to SU. Now, upon looking at this, these appear to be congruent triangles by HL. All right, so let's go ahead and tackle this then. So I'm going to make these pictures a little bit smaller just for me on my tablet so that I can write a little bit more clearly. But that certainly helped me get the idea of what I want to do here. Maybe I can put that up here in the corner. And I'll relabel my little Q. There we go. Oh, and my T got missing. T. Okay. All right, let's get to writing. So, let's talk about those right angles first. Now, I'm not doing side angle side or angle side angle, right? I'm doing HL. So with that being said, I need to make sure I have right triangles in here. So I'm going to say triangle QRP and triangle TUS are right triangles because if a triangle has a right angle, it's a right triangle. Okay, so that helps me tackle the triangle part. They gave me the leg, so that's good. So now I have to talk about the hypotenuse, and that's going to take some work because remember I said I needed to do some addition to accomplish that. So first thing I'm going to do is talk about SR being congruent to itself. And that's our reflexive property. Okay, so now the things that I'm going to be adding are SR, but to the congruent pieces that they gave me, which was PS and RU. Okay, so those are being added. All right, now what's another name for PS and SR? That's PR. What's another name for RU plus SR? That is SU. Okay, and that's my addition. Okay, so now that I know that those segments are congruent, that gave me the hypotenuse I was looking for, so now I can state that my triangles are congruent by HL. triangle QRP congruent to triangle TUS by HL. All right, now the rest of this proof is going to flow very similar to what we did in the last proof by using our supplements. So I'm going to have to get in here that angle 2 is congruent to angle 4, and then angle 1 is congruent to angle 3 because supplements of congruent angles are congruent. Now, before I do that, I'm going to have to tighten up my space a little bit in here. Ta-da. And then for sake of keeping the video as short as I can, because this is going to be a long one, I am going to then just insert the last few steps because we just did it in a similar proof. So, and boom, there you have it. That's where I'm getting 2 congruent to 4 because those are corresponding parts of congruent triangles. From there, I know that because 2 and 4 are congruent, 1 and 3 have to be congruent because linear pairs are supplementary and supplements of congruent angles, which I just stated were 2 and 4, are also congruent. All right, on to the next proof. I'm giving you quadrilateral ABCD with diagonals AC and BD. I'm telling you angle 1 is congruent to angle 2, and BD, which is this segment right here, bisects AC at E, which means E is a midpoint, and therefore AE must be congruent to EC. Notice how I didn't mark up DE and EB. BC or BD is bisecting AC only, not the other way around, so do not assume that. Now, my goal is to prove that this is a parallelogram. So I'm thinking through my ways I could do this. I could get both pairs of opposite sides parallel, both pairs of opposite sides congruent, diagonals bisect each other. I also could do one pair of opposite sides that are both congruent and parallel, and I actually think that's the way that I'm going to approach this. And the reason I'm thinking that is because solely based on angles 1 and 2 being given, those are alternate interior angles, which means it must be true that DC and AB are parallel. So right there you have one piece of information. Now, additionally, if I can prove these 2 triangles congruent, the top and bottom one, maybe because I have some vertical angles in there, so by angle, side, angle. Then, if these triangles are congruent by angle, side, angle, it must be true that their corresponding sides are congruent, and there you have it. I have a parallelogram by one pair of opposite sides, both congruent and parallel. All right, so first thing I'm going to tackle is those parallel lines. So let's say it's step 2 that AB is parallel to CD if alternate interior angles are congruent, lines are parallel. All right, now from there, let's talk about those vertical angles. Okay. Now, in order to do angle, side, angle, remember, I still have to talk about these sides. All they told me is that I had a segment bisector. They didn't tell me that those segments were congruent. So I'm going to have to do 2 steps here. I'm going to have to talk about E being a midpoint, and then a midpoint divides a segment into 2 congruent segments. So first things first. E is the midpoint of AC, and that's by definition our segment bisector. Oops, I'm sorry. Ooh, I started to do what you guys do. A segment bisector intersects a segment at its midpoint. Whew. I almost started doing what you guys do, where you start blending it with a midpoint. That's what's coming next. So now it's step 5. I'm going to say AE is congruent to EC. A midpoint divides a segment into 2 congruent segments. Okay, cool. So now let's do my little fact check here, because remember I said I was going to prove the triangle is congruent by angle, side angle. I just talked about the sides I needed. I talked about the verticals, so that was an angle. Angles 1 and 2 were given to me, so now I've talked about everything I need to talk about. Those are my 3 pieces of information. So now I can say my triangles are congruent. So in the corresponding order, I'm going to say DEC and BEA. And that's angle, side, angle. Okay. Now remember our end goal here. We're trying to prove a parallelogram. So I got the triangles in order to steal these sides right here. So I'm going to say that DC is congruent to AB. And now I have exactly what I needed. I have the parallels, and I have that they are congruent. So now I can say I have a parallelogram. So if one pair of opposite sides are parallel and congruent, the quadrilateral is a parallelogram. Done. All right, we are almost done here. 2 more proofs. Okay, so I am giving you that ABP, which is this triangle right here, is congruent to CBP. So my green little triangles right here, those are congruent, which means all the corresponding sides and angles are congruent, so that's great. I'm then giving you ADB, which is this angle right here, is congruent to CDB. Okay. And I'm also telling you that AD is congruent to BC. I want to prove that this is a rhombus, and specifically my hand is getting forced by using a diagonal property. Okay, now first of all, when we prove a rhombus, we have to first prove it to be a parallelogram, so keep that in mind. So I'm going to have to do parallelogram first, and then I'll get to rhombus. Now, parallelogram, let's tackle that thought process. I'm noticing in this picture they gave me alternate interior angles congruent, which would help me get AD parallel to BC. There's that Z shape. There you go. Now you have one pair of opposite sides, both congruent and parallel, and that gives you the parallelogram. Great. Now, the diagonal property is interesting because what I'm going to have to do is prove that the diagonal bisects the angle. Okay? So we're going to have to think through how to use some congruent angles in there to justify that. Now, something that I haven't really used yet is the fact that they gave me congruent triangles. If I have those congruent triangles, that means their corresponding angles are congruent. So, if I kind of like zoom in here a little bit to make this bigger, so I can write in here, that means that this angle is congruent to this angle because those are corresponding angles of congruent triangles. If those angles are congruent, then it must be true that BD is bisecting it. Okay? If BD is bisecting it, then that means that ABCD must be a rhombus, because if a diagonal bisects an angle, then the parallelogram has to be a rhombus. Okay, so jotting down some thoughts here. Again, I'm going to get parallelogram by getting one pair of opposite sides, both parallel and congruent. I'm going to get rhombus because I'm going to show that BD, which is a diagonal, bisects angle ABC. Okay, so that's my game plan. All right, so let's get that parallelogram. So remember the alternate interior angles they gave me that were congruent? Let's get those sides as a result parallel. Now I can at step 3 get a parallelogram because now I have one pair of opposite sides, both congruent and parallel. Okay, now we got to tackle the rhombus part. In order to prove that I have a bisector, I need to prove these two angles congruent. So I'm going to say angle ABP is congruent to angle CBP because corresponding parts of congruent triangles are congruent. And that allows me then to get a bisector. And my justification is, if a segment divides an angle into two congruent angles, it's an angle bisector. All right, so now that I've proven that BD is bisecting our angle B up here, then I can say that I have a rhombus. And my justification is, if a segment divides or bisects an angle, the parallelogram is a rhombus. Now, it's important to note that this theorem is only valid if you have first proved it to be a parallelogram, which I did. All right, one more final proof. All right, so for our final proof, we're looking to prove that ABCD is a square. They're giving me that it's a rhombus, so that's really good. That's a lot of information. And I'm also being given that ABX, which is right here, is congruent to BAX, which is right here. In order to prove that this rhombus is a square, that means I'm going to have to show ultimately that it has a rectangle property. So rectangle properties would be something like showing that it has a right angle, which I think is going to be hard to accomplish in this, or showing that diagonals are congruent. So if I can show that AC is congruent to BD, then that would prove that this is a rectangle, and a parallelogram that is both a rhombus and a rectangle has to be a square. So since I'm trying to get diagonals congruent, because that just seems to be, based on what I'm given here, the appropriate approach here, I'm going to start thinking about triangles that I could get congruent as a result. So let me do some colors here. Let's try to get this triangle, which I've outlined in purple. So that's A, B, D. Can I get that congruent to this ABC? I'm going to redraw that. Still feel like those aren't my best drawings, but that's what they are. Okay, let's put in some markings here. So they gave me that in this purple triangle, this little angle B is congruent to this little angle A. Now, the thing about a rhombus is that all sides are congruent. So in my picture here, I'm actually going to just do that. all of those are congruent. So additionally, I can put those in these pulled out diagrams as well. Okay, now here's where I'm in a little bit of a pickle because this spells out side-side angle, and that's not a criteria to prove triangles congruent. So I'm going to have to get kind of creative here. There has to be a reason why they gave me those two angles congruent and how I could use those somehow. So thinking through my picture, I have a bunch of stuff congruent that I can use. So if I just start marking some things up, like I'm thinking, okay, well, if these two sides are congruent and this is a triangle, that means the opposite angles have to be congruent. So I would have this angle right here congruent to this angle. So again, because these two sides are congruent, those opposite angles would be congruent in ABC. Now, if I think about it over here in my purple triangle, I know these two sides are congruent, which would mean the opposite angles are also congruent. So here and here. So it's a little bit of a confusing picture, but if you look in my pulled out pictures, it's these two sides congruent giving me these opposite angles congruent. And these two sides congruent giving me these two angles congruent. Now, the thing is, that's the tricky part about this proof, is that even though I know intuitively that these two angles are congruent, angle D and C in the pulled out picture, I still have to justify that they are. And I'm going to have to use substitution in order to accomplish that, because really all they told me was that these two angles are congruent, which maybe I should highlight them here. So like this ABX, which that's corresponding to here and here. I don't have enough information just yet without going through the substitution to then justify that D and C are congruent. But if I can get that, then that's going to help me get the triangles congruent by angle, angle, side. Now, if I know the triangles are congruent by angle, angle, side, then that means that BD is congruent to AC, and then we're all good to go. So kind of jotting down my thought process here. Let's kind of like write out what exactly I was saying. They gave me this. Right? Now, based on really the same theorem, the reason these two sides were congruent gave me these two angles. So let's jot those down. Now, instead of saying ADB, I'm going to make it be ADX because I think that's going to help you see it better with the substitution. So that's this angle right here. And then this angle B is technically ABX. Now, likewise, in my pink triangle, let's talk about these angles. So I'm going to call this BAX because that's right up here, BAX. And this would be BCX, BCX. Okay, so let's look at what I've written so far. This is my true statement, right, that they gave me. The other two things that I wrote down were based on two sides of a triangle being congruent. Well, here's ABX, here's ABX, here's BAX, here's BAX. Look at what's left over after doing a substitution then. It must be true that ADX, which would correspond right here, is congruent to BCX, which corresponds right there. Once I've then proved that these angles are congruent through that substitution, then the triangles are congruent and then you're good to go. But this was definitely a tough diagram to dissect, and it was really all based on why they even wanted me to have this piece of information to begin with, so I had to do something with that. All right, so let's start writing this up. All right, so first things first, I'm going to say all the sides of a rhombus are congruent. So I'm just going to list them out in a string. Okay, then using those congruent sides, that's what allowed me to get opposite angles congruent. So I'm basically going to write all of this over here. Actually, you know what I can probably do? Haha, look at that. So that's nice for me. Okay, so I just kind of moved that on over there. Okay, awesome. And then as a reminder, because of this, that's why my next line is going to make sense by substitution. Equals plugged in for equals. Okay. So I've got the sides, they gave me an angle, and I did some substitution to get the third piece of information, so the second angle. So now I have my triangles congruent by angle, angle, side. So I'm going to say ABD is congruent to, so ABD would correspond to BAC. Okay, and now again, the whole point was so that I could get my diagonals congruent. So that's now AC congruent to BD. Okay, now I can say it's a rectangle. And that's because if diagonals are congruent, a parallelogram is a rectangle. And now that I've proved that it's a rectangle, and remember they gave me that it was a rhombus, I can then say it's a square. So if a parallelogram is a rhombus and a rectangle, it's a square. All right, this was certainly a lengthy video. I hope it helped. Good luck studying.